Hello dear students. So I, Vikas Agarwal, I'm back here to take the next session of NSEJS Basics to Advanced series. So let's see what we are supposed to cover in this series and where we are. So all the topics that I will be covering in this series are listed here, and this is the sequence in which we will be covering them. And currently we are doing calculus, or we are doing basic maths, and in this also these are the topics that I have to cover, and out of these topics these are the ones that I have taken in the previous sessions, and today we are going to cover integration. Within integration also there are two things that we are going to learn. The first one is how to integrate, that is learning to integrate, and the second one is meaning of integration, like what exactly or where exactly do we need to integrate. So let's begin, guys. So because this is our introduction to integration, we need to first talk about it, like what exactly it is. So guys, in the previous session, okay, we learnt about differentiation, and if you have seen the previous session, you would know that differentiation is another operation, a new operation that you have been exposed to. All right, all the mathematics that you have been doing till date from your junior grades, all right, that mathematics involved four operations, primarily four operations: addition, subtraction, multiplication, and division. All right, and in this also we can say that addition and subtraction, they are the inverse of each other, or they are the reverse of each other. Multiplication and division, they are also the reverse of each other. Similarly, differentiation and integration are reverse of each other. So when whenever you are learning a mathematical operation, a new mathematical operation, you are also learning about its counterpart. So similar to that, like on the same logic, if we have learned about differentiation, we must also learn about its counterpart, which is integration, which is what we are going to do in this session. Remember guys, I told this in the last session that all the mathematical operations have got an operator symbol. There is a way to denote the mathematical operation. The same was true for differentiation. The same will be true for integration. So before we start, we must first learn to write the symbol properly. So to make it easier for you to understand, I will keep comparing with differentiation. So in differentiation, we learned that the symbol involves two D's, one D in the numerator and one D in the denominator, and then we write something here and then we write something here. Okay, what we write here is the entity with respect to which we are differentiating. Usually we write a x here and we say differentiation. Okay, differentiation of whatever is written here. For now nothing is written here, so let me just write a blank space. So differentiation of whatever with respect to x, whatever we write here, we differentiate with respect to that. If I write a y here, we differentiate y with respect to x. So the symbol involves 2D, and then it involves two parameters, y and x. Whatever you are writing in the denominator, you are differentiating with respect to that. Whatever you are writing here, you are differentiating that entity with respect to what you have written at in the denominator. This is the symbol for differentiation. Now likewise, just as the symbol of differentiation has the two permanent D's, okay, in a similar manner the integration symbol also have few things which are permanent, and those involves an elongated symbol f. Okay, it's not really an f symbol, but if you are looking at the symbol for the first time, the best way to interpret it is it's the English alphabet f in an elongated manner. So this symbol will always be there in integration, and then there a d will always be present. Okay, and the blank spaces would be here and here. So whenever you will see the integration symbol, you will see an elongated f symbol, you will see a d symbol, and then there would be something written here and something written here. So just as the d by d is a permanent thing to see in the symbol of differentiation, here integration symbol, this is called the integration symbol or the integral, and this d, they are the permanent entity. Whatever you write here, you say that you are differentiating with respect to that. Here, whatever you write here, you differentiate with respect to that. Okay, so let's say if I write an x here, Okay, so I will say that I am integrating with respect to x, and whatever you want to integrate you write here. So now I will read this symbol as integration of y with respect to x. So I hope reading the symbol is clear to you and the symbol itself is clear to you. Okay, so if you're not, you can avoid making these brackets. I made those brackets to make you understand that something will come here and something will come here. Otherwise, the same symbol can also be written. Rather, most of the times you will find it written like this. Okay, not in separate colorings, but I'm writing it to make you realize that what is the permanent thing that you will see and what are the things that can change. So this is integration of y with respect to x. Okay, so that is first thing. Now next thing, you can integrate y with respect to x. Okay, if let's first talk about differentiation. You can differentiate y with respect to x if y is a function of x. All right, if it is not a function of x and you're trying to differentiate it with respect to x, you end up getting a 0. Okay, now here as I said earlier that integration is the reverse process of differentiation. Let me first elaborate on the meaning of this statement. So what does this mean? So suppose if I say that differentiation, okay, this is something that you would be knowing by now. If I say differentiation of x square with respect to x, all right, differentiation of x with respect to x, this is 2x. Okay, then integration of 2x with respect to x should be equal to x square. Are you getting it? On differentiating x square or on differentiating something, if you get something, then integrating this thing should give you this thing. So that is why we are saying that integration is the reverse process of differentiation. I hope you understand this. Right now I have written it in English. I will soon write it in mathematical symbols also. But first let's understand the meaning of the statement that integration is reverse process of differentiation. I hope you understand this. You are differentiating anything to get something. You integrate this something, you will get the anything that you differentiated. So that is what I mean. Okay, but there is a very important thing to be observed. Notice that if I differentiate, let's say x square, we know we end up getting a 2x, which means that if we integrate 2x, okay, with respect to x, we should end up getting a x square. Okay, now also pay attention to the fact that if I differentiate x square plus 10, let's say, x square plus a constant value, we will end up getting 2x plus 0, which is same as 2x. Okay, so by this logic, integration of 2x dx should give us x square plus 10, but this is something which is odd. Okay, if I hide this part from you, if I don't let you guys see this half of the board, on looking here you will see that integration of 2x is coming out to be x square, but when you look here you will say integration of 2x is coming out to be x square plus 10. Something is wrong. Like, we can't have two answers for the same question. If integrating 2x with respect to x was the question, or it was the desired task to be done, then we are getting two different answers. Or are they really different? Are they really different? So guys, you might have noticed this, or you might have understood that if you are differentiating, like if there is a function with a constant added to it, okay, the differentiation of this constant will always end up being a 0. And when you try to integrate the outcome, if this part is hidden from you, you will never know that you should add a constant. So we can make a general rule. that whenever we are integrating something and we are getting an answer, we will write a plus c here. We will write this is something what I'm trying to say, that suppose you differentiated y to get something, some function of x. For example, here you differentiated x square to get another function of x. Okay, then integration of this function with respect to x should give you y, but you make it a point that you write a plus c here, so that you tell everyone that you are intelligent enough, you are knowledgeable enough to understand that there could have been a constant added to this y. Okay, so please remember this. Okay, now if you have understood this, like there are two things that I have explained till now. First, how to write the integration symbol. Second, whenever you are integrating a function or something to get an outcome, you must always add a constant to that outcome. All right. Next thing that we have to notice is that just as what we did in differentiation, the same thing we are going to do for integration also. What does this mean now? For differentiation, there was a set of formulae that we learned. There was a set of rules that we learned. Using the set of formulae and using the set of rules, it became possible for us to differentiate any function given to us. In a similar manner, there are a set of formulae in integration that we need to learn. All right, there are a set of rules in integration that we need to learn. Using the set of formulae and the rule, we will be in a position to integrate most of the function. Why am I saying most of the function? Because there are functions that exist which cannot be integrated. So there are such functions. Okay, these things will be taught to you by your maths teacher in detail when you study integration as a complete chapter. Right now, I'm only telling you the parts that I need you guys. I need to explain physics to you guys. Okay, coming back, there will be a list of formulae that we need to learn. There will be a set of rules that we need to learn to become good at integration, which basically means to become capable enough to integrate the common functions which are going, which we are going to come across when we study physics. Okay, another list of formulas, sir. We just learnt so many formulae in differentiation. Now you are making us learn another list in integration. Relax. The formulae for integration that you need to learn are the reverse formulae of differentiation. Okay, so we need not really learn the new formulae. It's like that if you have memorized the differentiation formulae properly, then you would be very good in integration also. So, let me write the list of formulae. I will start with the more easier ones. What do I mean by that? You know that if you differentiate sine x, you get cos x. Therefore, if I integrate cos x with respect to x, remember to write this. Many times students forget to write this. They just make the integration sign and write the function, which is an inaccurate representation. The outcome would be sine x, and I am intelligent enough to remember to put a c here, plus c. So if you differentiate sine x plus c, you will get cos x plus 0, which is there. Okay. So, and guys, notice that this is not something new to you. You already knew that differentiating sine x gives us a cos x. Therefore, integrating a cos x will give us a sine x. Now, what about differentiating cos x? Differentiating cos x gives us a minus sine x. Okay. So, integrating sine x should give us a minus cos x. If you don't believe me, you try it the other way around. You differentiate this. If you differentiate this, let me do it here just to explain this. If I decide to differentiate minus cos x plus c, I would be writing minus of d by dx of cos x plus d by dx of c. Okay, this is what I would be writing, and then this would become minus sine x plus 0, and therefore sine x. So we will get the like if we differentiate this thing, we get sin x. I've proved that. So like nothing, not really a very fancy proof or something that was very much needed. Those of you who could get it um, yourself, well and good. Those who couldn't, watch the replay again. Okay. So, okay. Yeah. Okay. Can we make more such formulae? Well, let's finish the trigonometrical formulae. We know that differentiating tan x gives us sec square x. So integrating sec square x will give us tan x. Okay, let's write some more. We know that differentiating sec x gives us sec x tan x. So integrating sec x tan x will give us sec x plus 3. Integrating cosec x cot x will give us minus cosec x plus c. See this, everyone. All right. Yeah. Okay. And then finally, differentiating cot x gives us minus cosec square x. So integrating cosec square x dx will give us minus cot x plus c. So whatever trigonometric formulae we learnt in differentiation, okay, we have simply reversed them. Okay, to get the formula for integration. Now we can get more such formulae. We will do that. Notice, guys, notice. If we differentiate x square, okay, we get 2x. If we differentiate x cube, okay, with respect to x, we get 3x square. If we differentiate x raised to power 4, we get 4x cube. I'm writing so that I can notice the trend. Now, what I can do, I can take this 2 from this side and put it on this side. I can take this 3 this side. I can take this 4 this side. And not only that, I can then take this half, which is constant, inside the derivative symbol also. So this can be written as d by dx of x square by 2 is equals to x. Similarly, the next one can be written as d by dx of x cube by 3 is equals to x square. D by dx of x raised to power 4 by 4 is x cube. Do you see a trend here? Whatever number is appearing here, we are getting one more than that here and one more than that here. So the general rule that we can make is this. The general rule that we can make is integrating x raised to power, let's say, m with respect to x will give us x raised to power m plus 1 by m plus 1 plus a constant. That's a different thing. So that would be the general rule that you have to remember. Okay, for integrating polynomials. This is a polynomial, so integrating polynomial, again check it out. When you are integrating x cube, you will get x raised to power 4 by 4. So when the power is 3 here, you get 4 and 4. When the power is 2 here, you get 3 and 3. When the power is 1, you get 2 and 2. So when the power is m, you get x raised to power like m plus 1 divided by m plus 1. So that is the general rule. Okay, so we have talked about the trigonometric function, we have talked about the polynomial function. Let's talk about the exponential function, which I think is the easiest one. You know that differentiating e raised to power x gives us e raised to power x. So integrating e raised to power x will also give us e raised to power x, but with a constant. Okay, we can also talk about like a more generalized version of this, integrating a raised to power x dx. Okay, that will give us again a raised to power x divided by ln a. Okay, divided by ln a. Okay, so this is the exponential functions. Then if we integrate 1 upon x dx, we get ln x. plus c. Sir, is this not a polynomial, like, or what if I write x raised to power minus 1 and use this formula? If you choose m as minus 1 to and use this formula, you will end up getting a 0 in the denominator, which means this won't be defined. So you can't really use this formula if m equal to minus 1. So maybe I can mention it here that m should not be equal to minus 1. If m is equals to minus 1, it becomes 1 upon x. For 1 upon x specifically, we have a different formula, which is this. Alright, so guys, all these formulas that I've written here, I've written them by reversing the differentiation formula. Okay, now these are the formula that you need to remember. Now there are certain rules, just as there were rules in differentiation. So you need to keep in mind these rules, and these are pretty much, few rules are similar to what we have learned in differentiation, few are different. So integration of y1 plus minus y2, okay, this would be same as integrating y1 and then plus minus integrating y2. Okay, so that is one thing. I'll give you an example on this. I'll give you an example. Okay, integrating, let's say, x cube plus sine x. So these are two different functions. Okay, so we will write integration of x cube dx plus integration of sine x dx. Okay, so this will become x raised to power 4 by 4. I'm using the polynomial thing, and then sine x, integration of sine x becomes minus cos x plus c. Now you may ask here, sir, you should have written c twice, one for this and one for this. But again, guys, two constants, sum of two constant will still be a constant, so you can just write one c. You can, in the end, you can add one c. So this is what this rule indicates. I hope this is pretty much clear to you guys. Okay, of course you need to do a lot of practice. Okay, so that is one rule. The next rule that I want to talk about, so the next rule would be this: integration of a constant into y dx, okay, is same as constant times of integration y dx. Now what does this mean? Let me give you example for this also. So if I am integrating 5x7, okay, then I can take 5 outside the integral sign, then x raised to power 7 dx. So this will become 5 times of x raised to power 8 by 8 plus c. Okay, so this is what I mean. You can take out the constant and then you can integrate. Okay, now the third rule that we have, okay, what if we are to integrate product of two functions? Okay, so if we have to integrate product of two functions, the first thing that you need to keep in mind is that you can't do this integration of y1 dx multiplied by integration of y2 dx. So please don't do this. This is the the first thought that comes to you naturally, but it is wrong. So please don't do this. Okay, now let me tell you what you're supposed to do. So you are supposed to write, see this, first function into integration of second function minus integration of differentiation of first function into integration of second function. Okay, so this entire thing needs to be finished if you are to integrate like two functions. Okay, the product of two functions. Okay, so for example, suppose we are to integrate x sine x. So can you see that this is product of two function? X is first function and sine x is second function. So we will write first function into integration of second. Now integration of sine x, I'm directly writing, that would be minus cos x minus integration of differentiation of first function. Differentiation of x with respect to x is 1 multiplied by integration of second function. Integration of second function was minus cos x. Okay, and this entire thing actually should also be written with dx. Okay, so dx here. So this will become minus x cos x. Okay, and then plus integration of cos x will become sin x. Okay, so this is your outcome. This is your outcome. And if you want to check whether this is correct or not, I will encourage you guys to differentiate this entire thing and check. Okay, or let me do it for you. So let us check, okay, that whether we did correct or not. So d by dx of the right hand side, this thing which is sin x, actually c plus sin x minus x cos x. Let's check it out how much it will be. So it will be 0 plus cos x minus, then we have to differentiate product of two, so we'll use the differentiation rule. So first function into differentiation of second function, okay, plus second function into differentiation of first function. So you can see from here we get cos x, and then this becomes plus x sin x, okay, and then this becomes minus cos x. So minus cos x plus cos x gets cancelled, and we are left with x sin x, which we should be getting because we integrated this to get this. So when we differentiate this, we should get this, and we are getting it also. So this is the rule that you need to remember. Of course, it is a bit complex. You will need more practice, a lot of practice in fact, to become good at this, but eventually everyone becomes good at this, so don't worry about this. Okay, by doing ample practice, you will become good at this. So guys, these are the rules of differentiation. This is how you differentiate. Then there are certain other things that you need to learn. What is that? The next thing that you need to learn is definite integration. Okay, the what we were learning until now was indefinite integration, and now we will talk about definite integration. So what exactly happens in definite integration? It is an extension of what we were doing. Suppose I asked you to integrate x cube. Okay, so till now it represents indefinite integration, but now if I put two numbers here, one number here and one number here, then it becomes a definite integration. For example, let's say I put some number, let's say I put 1 and 2 here. Okay, so this is called lower limit. This is called lower limit. Okay, this is called upper limit. Okay, now how are we supposed to use them? So what you need to do, you need to finish the integration first. So the integration would be x raised to power 4 by 4. Now you don't need to write the c. Now you don't need to write the c. Okay, why? I'll elaborate that in the next example. Once you have finished the integral, then the customary thing is to mention the lower limit here and the upper limit here. Like whatever you are getting as the outcome of the integration, put them in square bracket. Okay, then write the lower limit at the bottom right of the square brackets, write the upper limit at the top right of the square brackets, and then what you have to do, you have to first substitute the upper limit in place of x. So it will become 2 raised to power 4 by 4, and then you have to subtract. You have to subtract whatever you get by putting the lower limit. So by putting the lower limit, we will get this. Okay, so when you are doing definite integration, you first end up with a function of x, but then because you substitute the numbers, you substitute the limits, you end up getting a value. So this becomes what? This is 16 by 4. So 4 minus 1 by 4. So this is 15 by 4. So in definite integration, you end up getting a value. Of course, this value represents something. What does it represent is something that I'm going to tell you in a short while. But first you need to understand. So we did similar thing in differentiation also. Like after differentiating, I taught you to put, like if it is necessary, you can put some value of x, and when you put the value of x, you get a number, and that number indicates the slope of tangent. Okay, similarly this number here also represents something. What it represents is something that I haven't told you yet. I'm yet to tell you that. Okay, so this is definite integration. Let's do one more example. Okay, so I'll show you why c doesn't matter now. Suppose I am integrating, let's say cos x. Okay, I'm integrating cos x dx from 0 to, let's say, pi. Okay, pi. So the outcome would be sin x Okay, integration of cos x is sin x from 0. Okay, I said that I will explain why c doesn't matter. So let me write a c here and then we'll see. So I first need to substitute the upper limit. Okay, so okay guys, let's do one thing. Let's change this to pi by 2. Otherwise, the example will not be very meaningful. Okay, so this will become sine of pi by 2 plus c. Now this is what I get when I put the upper limit. And what do I get when I substitute the lower limit? I get sine 0 plus c. Now do you see what happens? Sine pi by 2 is 1 plus c, then minus 0 minus c. So this c is going to get cancelled every time you do the same calculation. Like you will substitute upper limit, you will get a plus c, then minus, you will substitute the lower limit, you will then get a minus c. The c's are going to get cancelled, and therefore writing c doesn't matter if you are going to do definite integration. It matters only when you are doing indefinite integration. Okay, now this is how to do the definite integration. Next, we are going to talk about the meaning of integration. Now, what does integration mean? So guys, indefinite integration really doesn't mean anything as of now. Okay, you will learn about it later on. Definite integration certainly means something. So suppose I wrote integration of y dx from lower limit to upper limit. Okay, now what does this mean? Okay, so guys, remember, we can differentiate or we can integrate y as a way. We can integrate y. Guys, there was one thing that I did not mention in the integration formula. There is one thing that I would like to mention. Let me mention it as a fifth formula. That would be integration of 1 dx, or simply integration of dx. That would actually be x, although it is redundant from this formula. If I put m as 0, x raised to power 0 will become 1. So integration of 1 will become x raised to power 1 by 1, which is x. Although this was redundant from here, but students struggle when they face this for the first time, so I wrote it separately. Now let me come back, okay, to the meaning of integration. So suppose y is a function of x, okay, and if y is a function of x, we can make a graph. Now x equals to 1, okay, x equals to x1, x equals to x2, okay, x equals to x2, x equals to x1, this graph itself, and the axis with respect to which you are integrating, that is x-axis right now. Okay, so you see that there is an area which is enclosed by x equals to x1, x equals to x2, the y, that means this function, this graph, and x-axis. You see four things here. Apart from the mandatory symbols, what are the mandatory symbols? This f was the mandatory symbol, this d was the mandatory symbol. Apart from this, you see four entities in the integral sign. The function, which is this graph, the lower limit, which is this line, the upper limit, which is this line, and the x-axis, okay, the x-axis. So there is an area which is bounded by these four boundaries. So when you finish this integral and substitute the limits, and then you get the numerical value, that numerical value is basically this area that you get. It is the area. We call it as area under the curve. Okay, we call it as area under the curve. It is understood that it is under the curve and between the x-axis and the two limits. Okay, so it is called area under the curve. So in this example, integration of cos x dx from 0 to pi by 2, I'll tell you what exactly we did, or what exactly that answer meant. So we got integration of cos x dx from 0 to pi by 2. The answer that we got was 1, I believe. It was 1. So what does this indicate? So if you make this graph, the graph of cos x, if you already know about it, if you don't know, let me show you. The graph of cos x is somewhat like this. Like this, okay. With this value, like being 1 and this at pi by 2. Okay, so we integrated. Let's first identify that what is this graph representing. So x equals to 0 is this line, x equals to pi by 2 is this line, then x-axis and the function. So this is the area that we calculated, and we calculated it to be 1. So this area is actually 1. Okay, if we find out this area, we will discover. And guys, this is not the quarter of a circle, please. This is not a quarter of a circle. Okay, so this area is 1. So the integral gives us the definite integral gives us the area under the curve. Okay, now there are few points that you must remember. What are those points? Okay, there are few points to remember. What are those points? Okay, so guys, if I write a, b as the limits and y dx, okay, so please remember that if a is smaller than b, generally that is the trend, that we put the lower number as the lower limit. If a is less than b, then areas above x-axis are positive. That means any function that is above x-axis and you're trying to integrate that with this rule, keeping the lower limit smaller than the upper limit, you will get a positive answer. Okay, and areas under x-axis will come out to be negative. Okay, they will come out to be negative. Now, what does this mean? Okay, let me demonstrate with a simple example. Okay, to demonstrate that, let me first draw a graph that we probably know. If don't know, then believe me that this is the graph. So this is the graph of sin x. Okay, this is the graph of sin x. This value is 0. This is pi. This is pi by 2. Okay, this is 2 pi. This is 3 pi. And this is 4 pi. So the function is sin x. Okay, now if I ask you to calculate sin x, okay, from 0 to pi, so notice that lower limit is smaller than the upper limit. Lower limit is smaller than the upper limit. Okay, and the graph in this region 0 to pi is above the y-axis. So if I finish this integral, I will get a positive value. Let us see. Integration of sin x is minus cos x. Okay, so if I put minus cos pi minus cos minus 0, like this. See, minus cos pi minus of minus cos 0. So minus 1, cos pi is minus 1, minus 1, you can notice it becomes plus 1, that is 2. So we got a positive answer. If on the other hand, if I try to integrate sin x from pi to 2 pi, okay, I notice the graph is below the y-axis. The lower limit is smaller than the upper limit. If I finish this, I will get a negative answer. Let's check. So minus cos x, okay, from pi to 2 pi. So we will write minus cos 2 pi minus of minus cos pi. Okay, so cos 2 pi is same as cos 0, which is 1. Okay, and then minus 1. Okay, so you get minus 1, which is minus 2, which seems logical also. It does look like that this area is same as this area magnitude wise, but when we calculate, we get a negative value. Here we are getting a negative value because it was below the y-axis. All right, so I hope this point is clear to everyone. Let's call this point as point number 1. Okay, now there is another point that you should remember. Okay, the second point, and the second point is that suppose if interchanging limits help you in any way, you can interchange the limit by putting a negative sign. And this is pretty simple also. You can notice it from here. If I put pi first and 2 pi later on a minus, so instead of using this example, let me prove it from here. Suppose integration of y gives us a function x. Okay, so when I say that integrate from a to b, it basically means that you will first substitute b and then you will substitute a. Now, if I want to interchange the limit, what will I get? If I interchange the limit, okay, I will get, notice, I will get fa minus fb, which is actually the negative of what I'm getting here. So therefore, this applies. So guys, these are the things that would be good enough for you for now. Okay, these are good enough for you. And the next thing is that where do we use this in physics? Okay, so there are many places where we are going to use this. As a beginning, we can start with noticing this. See, velocity is dx by dt. We learned about this. So velocity is derivative of x instantaneous. So v dt, we can take this dt on the other side, is equals to dx. So integration of v dt, okay, or integration of v dt is same as x, or you can say change in x. This is t1 to t2. So for x also, okay, you will write position after t2 time minus position after t1 time. This is integration of v dt from t1 to t2. Okay, so we will use this. When we will use this, I will explain this to you further. Similarly, acceleration is written as dv by dt. So in a very similar manner, a dt will become dv. So if you put the limits from t1 to t2, why t1 to t2? Because we are integrating with respect to time. Okay, so acceleration from t1 to t2 is same as v2 minus v1, that is change in velocity. So I'll elaborate further on this when we use them in physics, but they have got application and therefore we are studying about them. So guys, that finishes our basic mathematics part. I hope you enjoyed them. Next we'll start with one-dimensional motion. You are going to love it. I know the sessions up until now may not have been that entertaining as physics generally is because of the mathematical nature of these sessions, but from next one we are going to start with 1D motion, and I'm pretty sure that you're going to love them. So keep continuing watching these series, guys. Do subscribe the channel, and I hope you are already aware that we have launched a new channel by the name of Vedantu Science Olympiad channel, YouTube channel. So please find it on YouTube, subscribe to it, because we are going to post very good relevant content on that channel. Take care everyone. I'll see you in the next session. Bye bye.